And the topic at hand, it's a doozy. I'm going to read it out loud. It is electrical equipment maintenance and electrical safety in the workplace, integrating NFPA 70B and 70E standards. And following Paul Zoubek's presentation, we have Kyle going to jump in and talk about if you see dust, you need to adjust. I like to play on words. Emerging issues and control of silica, dust, hazards. But I also want to acknowledge a couple people here, some associations out. This webinar was brought to you by and sponsored by my employer, ehsInc, and the National Association of Women in Construction, NAWIC. And also want to acknowledge our national partner, Aramsco, hello, and also our affiliates, University of California, San Diego, UCSD Extended Studies, Association of Builders and Contractors of San Diego, ABCSD, Association of General Contractors of California, AGC of California, and then the California Water Environmental Association, or CWA, and the Division Santa Ana River Basin Section, SARBs to be short. So we want to acknowledge all of our affiliates and partners for that spotlight there, okay? Paul, Kyle, the floor is yours.
Okay, great. I appreciate the opportunity. I appreciate the opportunity to present on emerging NFPA topics. As Eric had stated, my name is Paul Zoubek. I have been doing safety for 34 years. I started my career back in 1989 as an industrial hygienist, which Kyle does for my firm at this point. But I got interested in the area of electrical safety following an incident that happened in an electronics component facility that I was working in. And one of the things that I thought was very useful as far as electrical safety program establishment, as well as in the interest of worker safety, is that of, first of all, NFPA 70E, which is electrical safety in the workplace. There's a sister standard that I'm going to get into that goes into electrical equipment maintenance, which is also emerging. We're on a 2024 edition of 70E, which is the electrical safety in the workplace, how to protect the worker during energized work. And then 70B was just revised this year in 2023 as far as the requirements for electrical equipment maintenance. So basically what I'm going to do in the very short time frame that we have is that we're going to look at codes and standards. Within NFPA, there are codes and there are standards. And I'm going to get into specifically how these standards and these codes play out in the area or the realm of electrical safety. Then what I want to do very quickly is get into the meat of things as far as the presentation, as far as highlighting why we have these two standards that are overlapping in the interest of worker safety as well as equipment maintenance, and then give you a little bit as far as some additional information that I can and some guidance as it relates to these particular standards. So if we go back, this is a facility I was in up in Northern California a few months ago. I was doing an electrical safety program assessment. My work scope was to go through this particular facility and identify electrical hazards, as well as the administrative controls that go with the establishment of electrical safety programs. So I came across this particular piece of electrical equipment. It was not really obvious what that is. As you can see, very obviously to the right, there is a panel board. I wasn't sure what this piece of electrical equipment was because it was equipment specific. So I looked at it and I saw that it had a hinged door. As a result of the person that was going through or escorting me through this electrical safety program assessment, I had him open that hinged door. And what did I see? A severe problem with that piece of electrical equipment. So things are not always what they appear, particularly when we're getting into electrical equipment maintenance. There's some very obvious problems now with that electrical equipment. Do I assume that that piece of electrical equipment is being properly maintained? Probably not, just by visual inspection. And also the other things that we have to understand is that just by visual inspection, we're not necessarily going to know that we're properly maintaining our equipment as a result. So that's very visual in that case. The other thing also that I wanted to go through real quick is that there are NFPA codes and there are NFPA standards. I had the opportunity to sit in on the technical meeting at the NFPA conference in Vegas this past June. And very interesting process where they go through standards. And as an NFPA member, you have the opportunity to vote yay or nay on the actual challenges and the revisions of the standards. So as a result, we have codes that actually get into, as far as NFPA is concerned. A code is a model. So NFPA 70, the National Electrical Code, is actual adoption as far as law is concerned. It's not, NFPA standards are not law. However, codes can be adopted into laws. Municipalities, for building inspectors, for example, adopt NFPA 70 as a code where they are able to enforce regulatory potential ramifications as a result of non-compliance to this type of code. A standard is not a code, nor is it law. However, it is a sequence for the regulators to follow in that of electrical safety program implementation in this case. They detail their detailed elaboration, nuts and bolts of meeting the actual code requirements. So there's a little bit of difference between NFPA codes and NFPA standards. We're talking about NFPA standards here as we're getting into NFPA 70E and 70B. OSHA technically does not enforce NFPA standards, but they can use NFPA standards to support citations. So, for example, if you've got a non-compliance to PPE requirement, for example, for arc flash, say you did not institute the proper arc flash equipment for a piece of equipment and something happens, OSHA will not actually cite on an NFPA standard. They'll cite within their own particular code or standard as it relates to the OSHA standards. The other thing also that I wanted to get into as far as the overlap of the standard, how I actually entitled this presentation. You basically have two overlapping standards, as the title indicates. You have NFPA 70B, which gets you into electrical equipment maintenance. Okay, so as far as preventative maintenance programs, it gets into your PMs, your frequencies, what you're supposed to do with common electrical equipment within the workplace to ensure that it is properly maintained. What that standard assumes is at some point that worker is going to encounter that system energized. Preferably, we like to lock and tag everything out, but that's not realistic when you're talking about electrical equipment maintenance. One of the things that everybody is familiar with, particularly with electrical equipment maintenance, is IR thermography, infrared thermography. There are insurance requirements, there are NFPA requirements that be done on a regular frequency. You cannot do that task with a system de-energized. That's where NFPA 70E comes in as far as protecting the worker. So what I promised you was I was going to go through a 5-step sequence. So if you're taking notes, once you do receive the presentation hard copy, just write down 1, 2, 3, 4, 5. What I want to do is take you through 5 highlights as far as requirements of these overlapping standards. First of all, the requirements for NFPA 70B for maintenance programs. These are your administrative controls. So basically, NFPA 70B lists requirements of an electrical maintenance program. So we not only have to have these health and safety programs for HAZCOM, for electrical safety, but we also have to have a program that establishes the sequence for maintaining our equipment. Within NFPA 70B, so you know where this came from, it actually came from Article 4.2 within the standard. So basically, as far as what I promised you, as I go through these forthcoming slides here, as far as overlapping considerations, NFPA 70B, they get into who's responsible for your electrical equipment, what electrical equipment that you have within your workplace that you're responsible for. You got to have a list Most organizations that I work with, have asset lists and so forth that list the electrical equipment that is within their facility or their site. Maintenance procedures as far as plans are concerned for actually maintaining that equipment, plans of inspections, the suitable tests, etc., and then the process to implement and document corrective measures. How does that overlap? Well, that overlaps into 70E. 70E requires us to do a risk assessment. It tells us to go into job planning. Talks about maintenance of electrical equipment, inspection of electrical equipment, and then our procedures as they relate as a result of maintaining that equipment for proper worker protection as far as part of our administrative controls. Step 2, got our programs. Now we have equipment condition. We have to look at proper electrical equipment condition in order to ensure proper worker safety. This is where we're getting into our engineering controls. What NFPA 70B does is it requires an equipment condition assessment. One of the questions that we had got pre-webinar was, I've had equipment sitting for long periods of time. What do I do with that equipment? Do I have to follow, NFPA 70B requirements? And the answer is yes. When you initially install that equipment, or if you are inheriting that equipment, once you put it into service, it has to be made a determination as to whether or not that equipment meets an normal versus an abnormal operating condition. Well, what the heck is that? Well, normal operating condition, when we do get into electrical equipment, goes into our proper engineering controls. If we didn't have proper engineering controls on electrical equipment, we'd be getting shocked off of it every time we turned on a light switch or worked at a control panel. It has to be under proper engineering control in the interest of worker safety as that portion of our hierarchy of controls. So what do they require? What does 70B require? They require visual inspections. They require mechanical inspections, electrical testing, and in most cases, unless you're testing for electrical resistance, or excuse me, the resistance as far as your electrical equipment is concerned, it's going to be done energized. So we have to take into consideration the 70E requirements. 70E defines normal operating condition as properly installed, properly maintained. That's what we're getting into. Used in accordance with its listing and labeling, those particular considerations that the manufacturer requires, as well as what 70B requires. Equipment doors are closed and secure, covers are secure, no evidence of failure. What I showed you earlier, one of my first slides, there is some evidence that that equipment is not properly installed. Therefore, it's not a normal operating condition. How does that actually equate to your your hierarchy of controls? Well, a hierarchy of controls, as you may or may not know, starts with elimination. It's not there, it can't hurt us, gets us into substitution for reduction of energy. But when normal operating conditions, as required by both standards, get into, it's that of the engineering controls. Once we have to do equipment maintenance, we get into an abnormal operating condition, or if we not have properly maintained that equipment, we are now in what the standard considers an abnormal operating condition. Therefore, we have to default to lower level controls within our hierarchy of controls, that being signage, job planning, our safety programs, our training, and then PPE being in the bottom of our hierarchy of controls. So that's step 2, as far as making that determination for initial how our equipment is. Step 3 gets us into field testing. Field testing shall be conducted to assess overall condition of electrical equipment as far as the standard is concerned, and that is where I pointed you out to as far as Chapter 8 is concerned. Type of test depends on the electrical equipment. What's really kind of nice about the standard is within the standard, you have a listing of common electrical equipment. So they have a task. This is for panel boards. If you don't know what a panel board is, it houses circuit breakers. It's probably the most common piece of electrical equipment that every facility has. Basically, they state that you have to do a certain type of test, and they say whether or not you need to do it in an energized or de-energized condition. If it's being done in an energized condition, the requirements of NFPA 70E are going to apply. So in my example, as far as configuration of circuit breakers within a panel board, that's what you're going to see in the standard. You're going to see a lot of pieces of equipment within the NFPA 70B standard that tells you what type of field testing needs to be done as a result of proper equipment maintenance. Some tests, as far as testing is considerations, operation may need to be performed while the equipment is energized. Well, if we're doing energized work, we're doing it in an abnormal operating condition. Therefore, the requirements of 70E are going to be have to be put into place as a result of PPE and our administrative controls and our awareness. Also, what I wanted to do is, and again, this is a lot of information as far as the overlapping of the standard, but I want you to know where this comes from. There are several articles within 70B, there's articles within 70E as far as sections that actually get us into the requirements per the overlapping standard. So for example, that the field testing requirements, they do code those within NFPA 70B is as 1 or 1A standards, and then 2 or 2A standards. Our online and our enhanced tests actually get us into energized work conditions. Our 2 and 2A get it into de-energized conditions. If we're in a 1 and a 1A type of condition, then we have to go through all these requirements. In the addition, what's in NFPA 70E as far as worker safety is concerned, to protect the worker from shock and arc flash. Step 4 gets us into maintenance intervals. So provide maintenance intervals by equipment type and condition within Article 9.2. I'm going to go back to the example of panel boards. Again, that's non-inclusive. There's a whole ton of pieces of equipment that we have in our facilities that do require a regular maintenance intervals. And that's kind of my pet peeve. When I do go into a facility and I see an arc flash label that's 10 years old, if I see that arc flash label has a date of, let's say, 2013, that's 2 frequencies ago. Basically, the minimum, the longest you can go for equipment maintenance intervals is 5 years in most cases. Infrared thermography is even more common. That has to be done at a more common frequency. But basically what you've got you've got this really nice table in 70B that tells you what you need to do on that equipment. Visual inspections, cleaning, lubrication, maintenance inspections, and electrical testing that they do require based on what that equipment is. And then, of course, you get into 70E, which tells you what you need to do to protect the worker, particularly in an energized work condition, okay, as far as PPE and your administrative controls. I do like the example of IR thermography, because everybody knows what it is. Insurance companies require it. This company requires it. You don't want to be in a situation where I give the example quite bluntly of burning down a building. Nobody wants to burn down a building. And a common source, a common root cause of electrical fires is the lack of doing infrared thermography. Equipment heats up. If it's aged to the point where it can't handle the heat that electrical energy is generating, you have the potential to start a fire. So infrared thermographies are specified that you do that in NFPA 70B. 70E actually gives you a task that says infrared thermography, what protective measures are going to be required in that case as far as that overlap is concerned. What I've done here, and again, I do apologize in the short time for a lot of information, but you will have copies of the presentations to be able to see where this stuff comes from. Really nice table in NFPA 70E that goes into tasks. Okay, so these tasks, it goes everything from voltage testing to infrared thermography to actually taking the guarding off of equipment. Because if you're doing that in an energized and you're exposing the worker, there's a potential for shock and arc flash as far as the worker is concerned. So in this case, I've got to take hinged or bolted covers off of a piece of equipment to do my infrared thermography. If I am doing that, I do have a likelihood of arc flash. Therefore, protective measures to the worker are going to be required. So as a result of 70B telling us we have to do something maintenance-wise, we now have to go to 70E to be able to understand how to properly protect the worker during that task that is being specified by 70B. Okay, this is the moment you've all been waiting for. Okay, so what I do like about this, and again, this is in the 70B standard. They go into frequencies of maintenance based on equipment condition. And I go back to the panel board equipment. So again, 60 months, that's the max. That's provided that we've judged that our equipment is being properly maintained. But if our equipment had shown that there are some issues, it gets more frequent. It goes down to 36 months if we had to do some repairs to that equipment in previous maintenance cycles, or we have missed maintenance cycles. So that example that I gave you of that arc flash label that says 2013 on it, that basically should be, evaluated every year. Again, what we're getting into and what I'm going to talk about in the last slide here is the business case for safety. If we're able to properly maintain our equipment, obviously it's more expensive to take a look at our equipment on more frequent than it is the longer frequencies that we're talking about as far as 5 years. So that's an incentive for us to properly maintain our equipment. Our last step, as far as system study intervals, in Chapter 6, they detail requirements for system studies, include up-to-date single-line diagram and short-circuit current studies that we actually get into as far as ensuring proper maintenance of our equipment. Now, what the heck is a short-circuit current study? Determine available short-circuit current at each point in an electrical system. Short-circuit current is the source of our arc flash. Basically, what a short is electrical energy traveling outside of its intended path. We've all seen arcing. We've all pulled a hairdryer or an appliance out under load, meaning that it's turned on. And what do we see? We see an arc coming out of that outlet. Obviously, 120 is way lower energy than most of our production equipment. So you're going to have more short circuit current as a result of higher energy or higher transient energy types of situations. The other thing also they require is that of coordination studies. So evaluate faults in a circuit. I was in a facility up in Chico, California, a couple of years ago, and what they did was they subdivided a suite. They made one suite into 2 suites, and they put a piece of drywall down the center of the suite. And what they did was they left the light switches in the suite that they were not occupying. So the light switches were in one suite, the panel board was in the other suite. How do you think they were turning the lights on and off every time they came in every morning? They were doing it at the panel board, and you're not supposed to do that. You're not supposed to open and close circuit breakers on a daily basis. That's bad for the circuit breaker. So in that case, there is a higher degree or a higher potential for that circuit breaker to not open when it's supposed to in an overcurrent situation. And last but not least, incident energy analysis. That's our arc flash study. As far as making a determination, the degree of incident energy that is going to happen or potentially happen in an energized situation if the worker's interacting with that electrical system. Most arc flash engineers that I have worked with will do all of these, but you have to make sure that these get done on at least a 5-year frequency, as provided we're properly maintaining our electrical equipment. But you do have to specify that to the arc flash engineer. So this is where it came from. In 70B, they required short circuit current studies, coordination studies, and incident energy analysis. And then the 70E actually has references to that as far as your administrative controls and so forth. Okay, so maintenance or guidance on electrical equipment maintenance. This is really nice. Look at all the chapters that you have in 70B that goes into types of work environments in the presence of electrical equipment. I just gave you a couple of them there. Hazardous locations, as far as explosion-proof equipment, panel boards and switchboards, circuit breakers, ground fault protection systems, motor control equipment. If you have solar systems within a facilities for photovoltaic, and obviously it's all these probably will not apply to one facility, but you do have that resource for you. And then chapters 2 and 3 and 70E get you into electrical equipment maintenance requirements. So as far as my summary is concerned, I think I'm right on time as far as giving you the abbreviated presentation. But basically what I've done here is I've given you those 5 steps. Establishment of electrical safety program. You're going to have overlap between the 2 standards. You're going to have the overlap as far as equipment condition, normal versus abnormal operating condition. Field testing, determination of maintenance intervals is based on equipment with worker safety. You're actually getting into the safety requirements in 70E. And then implementation as far as the study intervals, max is 5 years. I hope that you don't, have to do it less frequently than that. If you have to do it less frequently than that, then there's a problem, or there's some recurring problems with your electrical systems, and there's going to be, potential for injury as a result, or facility as far as loss is concerned. Okay, so I like to summarize, or I like to end with a business case for safety. Why do this? Obviously we want to make sure that the worker is safe, that the worker is not injured or worse as a result of these activities, but there's also a financial factor or a business case. An effective electrical safety program, along with equipment maintenance program, will lead to higher reliability. We know downtime costs money. If we are proactive as opposed to reactive, that should be a no-brainer. As far as ensuring that we have are able to get our product out. Just putting that very, very bluntly. Longer equipment life. Equipment, again, is expensive, particularly if you're talking about, very sophisticated production equipment, or even if your operations are not that sophisticated. You know what equipment costs. If we are able to extend the life of that equipment by properly maintaining that equipment, that's to our benefit.
So my name's Kyle Fisher. I'm a EHS consultant working for Zoubek Consulting. Got my background at a nuclear facility that was being decommissioned. So a lot of heavy demolition is kind of where Silica predominantly came up in my safety field, kind of seeing the challenges that presents with the workers. In that regard. So today I'm going to give an overview of emerging issues that are still in the field, the safety industrial field when it comes to Silica, as well as the OSHA's final rule that came out in 2016 that now needs to be fully implemented for all industries. A couple emerging issues that we're going to talk about, as well as MSHA kind of slowly adopting what we have in place now for general industry and construction into their field as well. So mining courts. So if you see dust, you need to adjust where that comes from, right? So with the current PELs and action levels that were implemented by OSHA, when we talk what we're going to talk about with 50 and 25 micrograms for the PEL and the action level, pretty much if you can see some visible dust over an 8-hour period averaged, there's a strong indication that you're going to be over those levels, right? So using controls that we're going to talk about to make sure that doesn't happen. So kind of talking about what can happen from either acute or chronic exposure to Silica over time, right? So just to kind of give some perspective of how certain people deal with silicosis over time. I know I've had family members deal with it in the past. Working in the concrete industry, right? So just slowly making it harder to breathe over time, right? So taking a straw about the diameter of a dime, try to draw air through that straw as time progresses. shrink the diameter of the straw, right? So even putting a bag over your head at one point because you slowly suffocate. So really trying to give an idea of what challenges are presented with silicosis over time. So we've all seen this either in our everyday lives, hopefully not in occupational settings, but unfortunately it does happen, especially in residential areas when it comes to construction, especially, right? So just a couple pictures, a couple examples of dust being used without any type of engineering control, right? So these are all areas of emphasis that we want to avoid, whether we work in general industry or construction when it comes to dealing with silica work evolutions, right? So OSHA came out with 2 standards, one for general industry and maritime, and then one for construction. What I'd like to do today is give a general overview of what each requires, the basic components of each, and then get into, like I said, a couple emerging issues that are still prevalent today when it comes to silica in the workplace. Silica being a little bit different than asbestos in regards to, asbestos we phased out, right? We found different products that can meet the requirements of what we used asbestos for in applications in the workplace over time, right? Unfortunately, with silica, we haven't found a component, a constituent to replace silica because it is such a great product for so many applications in everyday society, right? So it is a hazard that we are dealing with today that we work with still. So having up-to-date information is prevalent, following rules, regulations that OSHA has put forth is going to be vital in making sure that not only we protect the workers in our workplace, but also their families as well as the general public moving forth, right? So OSHA implemented their final rule 2016 and gave certain timeframes in which all industries needed to fully implement the controls in which they were presented with by a certain period of time. And I do have a slide we'll talk about. At this point, all of these controls need to be implemented now. So if you go in and you read the full rule, I believe there's about 600 pages, 600 plus, providing explanations, empirical evidence, data of why they came up with the guidelines, the criteria in which they did for specific practices and specific limits when it comes to permissible exposure limits as well as action levels. So the theory behind this is it's going to save lives, right? So there is a capital expenditure involved in making sure we implement silica safety guards, whether it's in general industry or construction. But the idea is it's going to save lives every year in the occupational field. That is going to outweigh the cost of in which a business is spending money as an expenditure to implement these controls, right? Silica, like I said, just because of the usefulness of the product, is used quite prevalently in all areas of construction and general industry when it comes to being used as a specific process, or whether it's around, or whether there's any facet of a building that pretty much needs any type of remodeling. In that regard, you're going to come into it in one way or another, right? So a couple background basics on it, right? It's a mineral. Most common form is being quartz. We're going to talk about with MSHA kind of what they're trying to do when they mine silica coming into quartz with such regularity, right? It is their job with these miners to mine the quartz, right? So a couple challenges and a couple up to date as of this year, 2023, guidelines and rules that they're trying to implement for their miners, for their workers, right? So used in construction, includes using sand, rock, and stone. It also can include man-made materials. And this is going to be another emerging issue that we're seeing actually locally for Zoubek Consulting up in Los Angeles. They're dealing with artificial stone, right? So there has been some cases coming out that have grabbed the attention of Cal OSHA, as well as now on a federal level with news stories coming out of acute silicosis happening to workers in their 20s that is becoming debilitating to the point where they're walking around with oxygen machines, right? And they can't even run, they can't play sports for any type of prolonged period of time, even to the point of not being able to play with their children, right? And we're going to talk about kind of some of the challenges that, like I said, are still prevalent today with emerging issues in that regard. So, and then dust containing this respirable silica, crystalline silica, right, is generated when we do any type of heavy activity that involves chipping, cutting, sawing, drilling, grinding. We saw the images in the examples that I gave at the beginning of the presentation that we see all too commonly without engineering controls, right? So the idea behind silicosis, right, too, is these particles are small to the point where they get trapped inside the deep parts of your lungs and they won't be able to come out. We can't expire them. And, there's not any type of treatment in that regard that's going to completely dissolve the silica from our systems. Hence, silica being a permanent debilitating disease in that regard. So, an overview of what silica can cause in terms of, physiological negative aspects of human health, right? So you have silicosis, which a lot of us have heard of, can also cause lung cancer. It's been known to cause, kidney diseases, autoimmune diseases, right? Chronic obstructive pulmonary diseases, COPD, which, like I said, I personally have seen and witnessed with family members, and it can be quite nasty in that regard. So these are areas of human health that we're trying to mitigate diseases being prevalent for. So, the higher levels of silica that employees are exposed to, right, the longer they're exposed to it, greater the chances of developing these diseases. But what I talked about earlier with the artificial stone, we are seeing cases of extremely high levels of silica for not even that prolonged periods of times. We're talking about any type of 5 to 7 years, right, where workers can be in an industry where engineering controls are not being used appropriately, properly, or in some cases they are, but not fully. And we are seeing these acute cases of silica popping up that are for a lifetime, right? So reasoning for the rule, we'll talk about the more important reasoning, obviously trying to improve human qualities of health. But mainly before 2016, there were some levels that weren't necessarily low to the point where they were confident. Research wasn't confident that they were going to prevent any type of illness or prolonged disease if they were at levels in which they were. And what am I talking about with that? So general industry formula, Pell, about equal to 100 micrograms per cubic meter. And then the construction shipyard were about 250 micrograms per cubic meter. So with empirical epidemiological studies and evidence, they showed that those levels were too high in the regards to if employees working in an industry for any type of period of time, more so prolonged period of time, usually 10, 20, 30 years, they would form some type of disease. So they need fixing, right? They needed updated, and we needed some type of role and guidance to make sure that we can implement silica protection in any type of industry, and it's practical to follow in that regard. So, like I said, previous Pells didn't adequately protect workers according to various studies that, like I said, in the rule, 600 plus pages are cited and quoted quite extensively in that regard. So, and then in addition, the more important reasons for the rule is we really want to prevent, debilitating diseases and improve human health and quality of life, right? So, when OSHA came out with the rule and implemented in 2016 and then gave varying dates for different types of industries to fully implement their section of the rule they needed to follow, they cited that this was going to prevent deaths for different types of physiological ailments and diseases such as kidney disease, lung cancer, silicosis, and other non-cancer lung diseases, right? So these were direct deaths from occupational silicosis, like something I'm going to implement what I'm going to preach to implement in your, your safety program is making sure we have good housekeeping, access zones to make sure that we're not taking that home to family members, in which case that can also cause more illnesses and death potentially from that, right? So 3 forms of silica, most common form being quartz, right? We do have cristobalite, tridymite as well. In the construction aspect, you'll see a lot of exposures from chipping, cutting, sawing, any type of drilling, grinding, sanding, crushing of concrete, right? There's a myriad of ways in which we can be exposed to silica, or your employees can be exposed to silica through construction activities. Exposures in general industry, maritime, right? Glass manufacturing, foundries, sandblasting. Another common one is packing, for quickcrete operations in a facility, right? Packaging a bunch of dry concrete and shipping it off to, a place like Lowe's or Home Depot, right? So examples of that. So industries and operations with exposures continued, right? So, if you all here today covered in one of these industries one way or another, I know from a little bit of background, we had wastewater operations, right? If you have to do any, constructions, modifications on those facilities as well, like I said, you're going to run into silica pretty much in any industry one way or another because of how good of a product is. And like I said, there's no plan to really substitute it today because we haven't found any type of a product to replace it yet. So getting a little bit to the general industry maritime kind of scope, what the rule outlines for general industry practices. Like I said, you're going to get these slides. So really what I want to do is highlight the main points. But these are all here that we can go into greater depth and look into, but make sure that all of the components are highlighted today, right? So for the action level, that's going to be 25 micrograms per cubic meter, measured over an 8-hour time-weighted average workday, right? So understanding that if your workers work a 10-hour, 12-hour shift, using the proper formulas to adjust to make sure that we cover, any type of varying levels in that regard for their time that they're working. But nonetheless, if you're under 25 micrograms, that is what we need to do to make sure that we're not exposing our workers to any type of silica. And then if we are adjusting from there, right? So a couple, agriculture operations not covered under this scope. And then general industry employers can follow the construction standard in very limited circumstances, when that's appropriate, right? So like I said, mainly the permissible exposure limit being 50 micrograms per cubic meter. So research has shown that basically anything over 50 micrograms per cubic meter exposed to regularly through a 40-hour work shift for any type of prolonged period of time, whether it's 5, 10, 15, 20 years, is going to show some type of adverse human health effect, right? So silica being a health hazard, right? If we're over this permissible exposure limit, we're going to have some type of negative consequence over a time, in the occupational work field. The action level being 25 micrograms as an 8-hour time-weighted average. If we're over this action level in any way, we're going to talk about the controls that we have to implement to make sure that we're protecting our employees from silica in that regard. So if we're under this action level, then we can proceed with work evolutions under a normal circumstance that don't necessarily fall under the criteria of this rule that we have to follow now, right? So like I said, an exposure assessment needed just in about any type of industrial work we do, right? So especially if we think that reasonably the action level is going to be exceeded in this regard, we need to perform an exposure assessment of one of 2 ways that OSHA outlines, right? So one being a performance option and one a scheduled monitoring option, and we're going to talk about both briefly, right? So the performance option, of course, exposures assessed using any combination of air monitoring data, objective data sufficient to accurately characterize employee exposure to silica, right? So this can be evidence from past processes that are similar in work evolution. industry-wide data that we can grab that is published, right? Somehow showing in some way or another that this specific process that we're working with this product with is going to make sure we're under that 25 microgram action level, or if we are above it, what engineering controls, PPE controls, what type of specific controls we're going to implement to make sure that we protect our workers properly, right? So, there's a scheduled monitoring option as well. Prescribed as a schedule for initial periodic personal monitoring. This is where you get into the industrial hygiene aspect of, silica exposure, right? So, and then OSHA lists within that specific industrial hygiene aspect, what type of levels you're going to get back on your personal air pumps, what we need to do, right? So if we're below the action level, no additional monitoring needed. Like I said, so if we're below that 25 microgram per cubic meter count, then we don't need to perform additional monitoring for that specific work evolution. However, there is different criteria once we start to get those levels raised, right? So if we are above the action level, in addition to making sure we're implementing proper controls to try and lower that level for our employees, we need to repeat the monitoring within every 6 months, and if we're above the PEL every 3 months, and then in order to make sure that we can make our testing validated in regards to making sure it's accurate. When 2 consecutive non-initial results are taken, 7 or more days apart below the action level, monitoring can be discontinued, right? So if we get 1 result that's standalone, we want to make sure that we have another day of testing with that specific work evolution that is similar, the same in that regard, to make sure that that can be repeated and is validated in that regard. So, and then just like when we do retraining, when we do any type of reevaluation for any type of exposure assessment, if the work evolution has changed, if we introduce controls, take controls out, work with different substances such as asphalt, for instance, we reassess and consider remonitoring in that regard. So, Appendix A, methods of sampling analysis. Commonly, we need to make sure that when we do any type of industrial hygiene monitoring, it's under certain criteria that OSHA outlines. So a couple examples of this, for instance, being a common NIOSH method that we use to draw our air samples from, which would be NIOSH 7500, which outlines exactly how to go about your sampling, flow rates, sample pumps, use of cyclones in that regard, an instrument to make sure the respirable silica dust is getting captured on the cassette, filtering out all those larger particles in that regard, and then making sure that when we send these cassettes into the laboratory, it's an accredited laboratory that can be not only validated in the court of law, but also make sure that we're giving accurate representation of sample results to our employees to make sure that they are, getting the accurate levels that they're being monitored for, right? So methods of compliance, hierarchy, controls. Paul highlighted on it a little bit in his presentation. We always want to use the best controls we can in terms of implementing controls, the most effective controls. This starts with engineering controls, right? So OSHA in their role really highlights that they would like to see engineering controls used, effectively, predominantly before we try and put employees into personal protective equipment such as respirators, right? There are certain challenges with personal protective equipment that we'll get into, as a lot of you probably know, user error, potential impairment of other work. There's heat stress issues involved with that. Like I said, engineering controls being what we want to implement first and foremost. And if we do implement engineering controls and we still cannot get below these 25 and 50 microgram limits, respirators can be used in addition to engineering controls, right? So the main idea being we're trying to keep our workers from breathing in silica dust completely. So a few examples here of unfortunately, what we do commonly see sometimes in industry or out in the field, people at home working with any type of material they're doing to renovate homes, or in the industry, right? So grinding stone without engineering controls on the left, and then, polishing stone using water to control the dust, showing that it is possible with engineering controls commonly prescribed with PPE and administrative controls. We can limit silica dust down below levels, so we don't have to take action in that regard. So another example, right? So grinding without engineering controls, using a vacuum dust collection system that's outlined in the rule, right? So another common work evolution, jackhammering, without engineering controls, big clouds of dust, and then using water spray to control dust as an adequate means of protection in that regard. And as you can see on the right, the employee is also using a respirator. So commonly what I've seen in my experience is the two are used in conjunction to make sure that we are adequately protecting our employees. So a written exposure control plan needs to be implemented to outline all of what we're going to do to protect our employees, right? So a few basic things it needs to have, right? So tasks involving the exposure, engineering controls, and housekeeping measures, right? So respiratory protection needs to comply with any type of respiratory protection program that they're going to have, right? So housekeeping, we don't want to take any of this stuff home with us to our families, right? So using compressed air for cleaning surfaces is a big no-no. Specific instances will allow for it, but OSHA outlines that we don't want to use that. And then medical surveillance, some capital expenditures to think about. We need to put our employees into in regards to putting them into a respiratory protection program. So medical opinions following the outline of that as well. So hazard communication being another training portion of this that we need to comply with, making sure that our employees know the hazards, know how to protect themselves against them when we make them work with them, right? So all parts of the general industry rule that are outlined for silica, right? So construction being similar, but there are some key differences, right? So we need to remain below that 25 microgram timeline. But there is an example of a table 1 entry we need to follow, right? So what is the table 1 entry? So for construction, basically OSHA has compiled a table with every type of work evolution that can be accounted for and how we're going to adequately protect the worker for them, for the ease of use of any type of construction employer to follow, to make sure that not only we're in compliance, but we can feel good about protecting our workers, right? So, and then any type of respiratory protection involved in conjunction with an engineering control. So, we'll give the example here and then in a practical sense with a picture, right? So handheld power saws, no matter the diameter of the blade, right? So in conjunction with using an integrated water delivery, depending on the hour time shift, whether it's greater than 4 hours or less than 4 hours, we need to have some type of respiratory protection. APF, for instance, is the example here of 10, right? So we need to protect for 90% of the constituents, the silica dust in this regard, that is going to be in the atmosphere, right? So an example of using this in a practical sense in a picture, right? So not only, as you can see, they have their integrated water system there, but we also need to use a respirator in this case, depending on their time shift. So in this picture, they're not using a respirator, right? So you can sense that their shift is less than 4 hours, right? So, and if they're using, the water system, the water integration system correctly, then a respirator can be avoided in this case, which ultimately we're trying to do because we're trying to limit the amount of PPE they use, because engineering controls, if used properly, hopefully can dissipate all of that dust and all of that exposure in that regard. So, like I said, list of table 1 entries, what they all cover. This list, OSHA really did a good job of trying to account for any type of work evolution when it comes to any type of even skid steers, using a water implementation system, any type of jackhammering, and this list, like I said, is in the rule in that regard. So So making sure that we fully implement the controls is going to be key in making sure we protect our workers. And this goes from employer down to employee, making sure that they understand how to implement these controls correctly, right? So, we can give them all the tools to implement these tasks, but we need to make sure that they know how to do them as well in order to make sure that the protection from silica in the work evolution is fully being integrated in that regard. So respiratory protection as well, if it's going to be used in conjunction with the engineering controls as prescribed by table 1, needs to, similar to general industry, needs to be used fully in compliance with the respiratory protection standards that should be outlined in your respiratory protection program. Written exposure control plan as well. I highlighted in red here, procedures used to restrict access. This is going to be key to make sure we keep the general public from being exposed, as well as taking it home to our families. Having a competent person on the job, making sure that they can take prompt corrective action and implementing this plan. Like I said, medical surveillance as well. And then here I've highlighted that by now, all of these standards need to be enacted at this point in time. So when they came out with the rule in 2016, they gave certain timeframes for all of these. They need to now all be enacted, right? So just a summary here, you can go back and look at it, the key provisions highlighted in this rule, as well as record keeping that you need to comply with for the record keeping portion of the rule and highlighted within OSHA standards. So like I said, a couple of the emerging issues we talked about still today, 27-year-old man now has a debilitating acute silicosis disease that he's going to be living with for the rest of his life. So silica, challenges here are still prevalent in everyday society. And then the MSHA as well, trying to hopefully, and this came out in 2023, trying to implement and adopt the OSHA rule to protect their workers, which is challenging because they mine silica, they mine quartz, right? So, but hopefully we can get these controls enacted as soon as we can in that regard. So some guidance and outreach, right? OSHA provides good tables, good fact sheets in that regard so that we can always follow up with for pertinent information.